Hi everyone, I am Chandakumari, Head of the Department of Chemistry from Majlis at St. Science College, Puramannur. I am here to introduce a small video on some physical chemistry experiments for the BSc Chemistry students of Calicut University. The learning outcomes are: number 1, the student will be able to perform the experiment independently in the chemistry laboratory. Number 2, the student will be able to complete the experiment successfully within a shorter duration of time. And number 3, the student will be familiar with certain chemicals, equipments and some laboratory techniques. So let me introduce this video, which is a small attempt from the Postgraduate Department of Chemistry, Majlis Arts and Science College, Puramannur. Now the first experiment we are going to demonstrate is RAST method for the determination of molecular weight, and this method is also for the determination of molar depression freezing point constant of a substance. Now this experiment depends on the depression in freezing point, which is a qualitative property. I hope you are familiar with qualitative properties. There are 4 qualitative properties you have already learned: lowering of vapor pressure, elevation of boiling point, depression of freezing point and osmotic pressure. And here we are making use of the depression of freezing point for RAST method. Now let us see what is a qualitative property. A qualitative property is a property which depends only on the number of particles and not on the nature of particles. So here we are depending on the depression of freezing point. That is, when a solvent contains a solute, or when we make a solvent a solution by dissolving a small amount of the solute in the solvent, the freezing point of the solvent decreases, and that decrease in freezing point is known as the depression. For example, water freezes at 0 degree centigrade, water freezes at 0 degree centigrade, and when we add a solute into it, the freezing point will be lowered. So that decrease in freezing point is known as the depression in freezing point, and that depression in freezing point is the principle behind RAST method. In RAST method, the question will be: number 1, to determine the molecular weight of the given solute B, and you are provided with W1 gram of the solid solvent A whose Kf is given. Or number 2, to determine the molar depression freezing point constant Kf of the solid solvent A, you are provided with a solute B of molecular weight M2. Now these questions can be answered just by determining the depression in freezing point, which is a qualitative property. Now depression in freezing point, we have seen that it depends only on the number of particles and not on the nature of particles. So depression in freezing point delta Tf is proportional to molality. Molality is the number of moles per kg of the solvent, and delta Tf is equal to Kf into m. And on expanding, we will be getting the equation as delta Tf is equal to Kf into W2 into 1000 by W1 into M2. So if we determine delta Tf, and then if we know Kf, then you can calculate M2, or if we know M2, then you can calculate Kf. So in both these questions, you have to determine only delta Tf, that is the depression in freezing point. So what is done is, we take W1 gram of the solid solvent. It is a solid substance, that is why it is known as a solid solvent. For example, naphthalene can be taken as a solid solvent. So W1 gram of the solid solvent is exactly weighed, and it is taken in a boiling tube fitted with a thermometer and a stirrer, and then we heat the substance in a water bath and then determine the freezing point. We will be noting the temperature at every 30 seconds, and we will see that at a particular time the temperature will remain constant. So, that is the freezing point of the solvent. Then cool the substance again, then add W2 gram of the solute B. Now, W2 gram should be very small because the qualitative property is applicable in the case of very dilute solutions. So, you can take 0.25 gram of W2, 0.25 gram of solute B, then add it into the solvent and then again determine the freezing point. So, you will see that the freezing point will be lowered, and the decrease in freezing point is delta Tf, that is the depression in freezing point. Then again we will note the time temperature graph, and from the graph you can take the freezing point exactly. Then a duplicate will be conducted by adding again a 0.25 gram of the solute B and then again determining the freezing point. So, you will be getting two freezing point depression values, two delta Tf values, and using these two values you can determine the molecular weight or Kf, whichever is required, and then you can confirm the value. Now, we will see exactly how this experiment is done in the real situation in a chemistry laboratory. Now, this is the experimental setup for doing Rast method. There is a boiling tube here, and we have taken exactly 5 gram of naphthalene, that is the solid solvent taken here for this experiment. And then this boiling tube is fitted with a 2-holed cork. Through one hole we have introduced a thermometer, and through the other hole we have introduced a stirrer, and it is kept in a water bath and then it is heated. It is fixed on a stand. This is a setup for Rast method. Then on heating, the substance will melt. So, we have to note the temperature at every 30 seconds. For that we are using a stopwatch also. Then for repeating the experiment with the solution, that is by adding solute, we have to cool it first, and then for that purpose we are using a air jacket. So, these are the equipments and chemicals required for Rast method. This is a solute, biphenyl is taken as the solute here. So, on heating you have to stir the substance. Now, the substance is getting melted. Melting point is same as the freezing point. So, the temperature is getting almost 80 degree centigrade. The substance is slowly melting. After melting, you have to raise the temperature 5 degree centigrade more than the melting point. See that the substance is completely melted, and you can see the temperature 85 degree centigrade. That is, you have increased the temperature 5 degree centigrade after the substance is melted. Now, remove the burner, then take out the boiling tube and then keep it in the air jacket. The air jacket is simply a beaker containing cotton in it. This is for the slow cooling of the substance. Then stir it well and then note the time and the temperature. That is, for every 30 seconds you have to note the temperature, and that will help you to draw the time temperature graph. You have to stir the mixture, stir the substance. Note the temperature for every 30 seconds. Now, the temperature is remaining constant. For 2-3 readings, the temperature is remaining at 80 degrees centigrade. Again stir the substance and note the temperature, and you can see that the temperature is decreasing. From 80 degrees centigrade, the temperature is decreasing to 79 degrees centigrade, and then to 78 degrees centigrade, and then 77 degrees centigrade. That will be sufficient for drawing the time temperature graph. Now you can see that the substance has solidified again. It is partially solidified. Now you have to add solute B to make this a solution. Now this is biphenyl, 0.25 gram biphenyl is taken here, and this is added to it. Close it again, and then keep it again in the water bath and heat the substance. Now this is the solution now. Initially we have taken only naphthalene. Now it is naphthalene plus biphenyl. That is what is called the solid solution. Now it is heated again, and then you have to repeat the experiment. Just as in the case of solvent, you have to determine the freezing point of the solution. That is, you have to heat it, melt it, then raise the temperature again 5 degrees centigrade more than the freezing point, remove it from the burner, keep it in the air jacket, stir it well, note the temperature at every 30 seconds, and then note the temperature which remains constant. That is the then from the two temperatures you can determine the depression in freezing point. Then again you have to do a duplicate by adding 0.25 gram biphenyl again to this mixture, heat it and determine the freezing point. So 2 times you will be getting the delta TF values, one with solute 0.25 gram, and the second case the weight of the solute will be 0.5 gram, because you have added 2 times 0.25 gram. So the total solid in the second case will be 0.5 gram. So you can determine Kf or M2 by using that equation. Delta TF is equal to Kf into W2 into 1000 by W1 into M2. So in this experiment you have to determine the delta TF. That is the only value to be determined by Rust method. That is, first you will see the freezing point of the solvent, then add a little bit of solute, that is 0.25 gram of biphenyl is added here. Again determine the freezing point. The freezing point will be lowered, and the difference is known as delta TF. So to confirm the value, again we are conducting a duplicate by adding 0.25 gram of the biphenyl again to this mixture, again determining the freezing point. So the only value to be determined from Rust method is delta TF. So now we have completed the experiment successfully, and we have determined the delta TF values, that is the depression in freezing point. We have determined the freezing point of the solvent, then the solution 2 times we have determined. So we have got 2 delta TF values, and you have to get the delta TF values from the graph. Correctly you can get it from the graph. Time temperature graph or cooling curves are to be drawn, and for this you have to take time on the x axis and temperature on the y axis. The scale is 10 division is equal to 30 seconds in the x axis and 10 division is equal to 1 degree centigrade on the y axis. And you can see that the temperature is remaining constant for at least 1.5 minutes. The temperature remains constant for 3 points, and you can extrapolate that line to the x axis in the case of solvent and the 2 solutions, and you can get the delta TF values in both the cases. Then from the delta TF value, you can calculate the molecular weight. You can use the equation delta TF is equal to Kf into W2 into 1000 by W1 into M2. Then M2 is equal to Kf into W2 into 1000 by delta TF into W1. Then substitute the values. Delta TF in this case it was 2.3. So, you can substitute 2.3 in place of delta TF. Then Kf is given here, in the question it will be given. Now, it is given as 6.95. So, you can get the value as 6.95. Then W2 is 0.25 gram solute. Then W1 is 5 gram. So, substitute all the values and you will be getting the result as 151.087. So, that is a molecular weight of the given solute B. Then in the duplicate, we are getting the delta TF value as 4.5. Then substitute 4.5 in place of delta TF and you can calculate the molecular weight again. And here the difference is the W2 is 0.5. That is the weight of the solute is 0.5. We have added 2 times 0.25 gram. So, totally the weight will be 0.5 gram. W1 is 5 gram, Kf is 6.95, all values are same. The only difference is in the value of delta TF and W2. Again calculate the value and in this case it was 154.44. So, you have got 2 values for the molecular weight, 2 results are obtained for the experiment. So, that is all for the Rust method. Thank you very much for watching this video.